Everything you think you know about finding another Earth is wrong. Stop for a moment. Breathe. Look up at the night sky and imagine that somewhere out there, 40 light-years away, a world orbits its star every 12 days, 8 minutes, and 37 seconds. A world that shouldn't exist. A world that's rewriting everything we thought we understood about the cosmos and our place within it. You think you're ready for this story? You think you're prepared to have your understanding of the universe completely shattered? Because what NASA discovered isn't just another planet. It's a cosmic contradiction that's forcing us to question the very nature of reality itself. The discovery began with silence. Not the kind of silence you experience on a quiet evening, but the profound, absolute silence of space. A silence so complete it makes your skin crawl. Picture this. You're floating in the vacuum between stars, where sound doesn't exist, where the only thing you can hear is the rhythmic pulsing of your own heartbeat echoing through your helmet. Now imagine that in this infinite void, something impossible is happening. Something that defies every law of physics we've spent centuries proving. Something that makes the discovery of water on Mars look like finding a puddle in your backyard. What if I told you that NASA's James Webb Space Telescope, that magnificent 21-foot golden eye peering into the cosmic abyss, has detected something that shouldn't be there? Something that challenges our most fundamental assumptions about how worlds are born, how they live, and how they die? You might think you're ready for another Earth-like planet announcement, another routine discovery to add to the growing catalog of 5,800 confirmed exoplanets. But this isn't routine. This is cosmic heresy. The planet they found, let's call it what it really is, a cosmic paradox named Gliese 12b, exists in a state that should be impossible. Imagine a world smaller than Earth, orbiting so close to its star that a year lasts less than 13 Earth days. By every law of planetary science we've established, this world should be a charred, airless rock. It should be a barren wasteland, stripped of any hope of atmosphere by the relentless radiation of its nearby star. And yet, as you're about to discover, this impossible world might be the most habitable place we've ever found outside our solar system. But here's where the story gets truly unsettling. This discovery isn't just about one planet. It's about what this planet represents. A fundamental crack in our understanding of how the universe works. You see, for decades, we've been operating under a cosmic assumption. We've believed that to find life, to find habitability, we need to find planets that look like Earth, that behave like Earth, that exist in conditions that mirror our own solar system. We've been searching for Earth's twin in a universe that apparently doesn't make twins. Think about the audacity of what we've been trying to do. In a galaxy containing over 100 billion stars, we've been looking for a cosmic needle in a haystack the size of eternity, and we've been assuming that this needle would look exactly like the one we already have. But what if we've been wrong? What if the universe is far stranger, far more creative, far more alien than we ever dared to imagine? The James Webb Space Telescope has been operational for less than 3 years, and already it's completely revolutionized our understanding of exoplanetary science. Every single observation challenges something we thought we knew. Every spectrum it captures, every atmosphere it analyzes, every world it examines, seems designed to humble our scientific assumptions. It's as if the universe has been waiting patiently for us to develop the technology necessary to see how little we actually understand. Consider this cosmic fact that will make your head spin. In the time it took you to read the last sentence, the Webb telescope captured photons that have been traveling through space for 40 light years. photons that left Gliese 12b when your parents were children, carrying with them the chemical signature of an atmosphere that shouldn't exist. These ancient messengers of light have traversed the cosmic gulf between stars just to whisper their secrets to a machine floating in the void near Earth. But here's what makes this discovery truly mind-bending. Gliese 12b isn't just another potentially habitable world. It's a world that's forcing us to completely redefine what habitable means. You think you know what conditions life requires? You think you understand the narrow band of cosmic real estate where biology can flourish? Think again. This planet is teaching us that the universe might be far more generous with its gift of habitability than we ever dared hope. The star that Gliese 12b orbits is what astronomers call a red dwarf, smaller, cooler, and longer-lived than our Sun. These stellar lighthouses make up about 75% of all stars in our galaxy, yet we've barely begun to understand the worlds that dance around them. Red dwarf stars are known to host small, rocky worlds, and at the moment, they're the best bet for finding habitable planets. But here's the cosmic joke. These stars are also notoriously violent, prone to massive flares that should strip away any atmosphere from nearby planets. And yet, Gliese 12b has not only retained its atmosphere, it might be thriving because of it. Picture this nightmare scenario from the perspective of a planet. Your star, the source of all your energy and warmth, suddenly erupts in a blast of radiation so powerful it could sterilize entire continents. This happens not once, not occasionally, but regularly, like cosmic clockwork. For any world orbiting close enough to such a star to be warm enough for life, these stellar tantrums should be a death sentence. And yet, analyses by both teams conclude that Gliese 12 shows no signs of such extreme behavior, raising hopes that Gliese 12b's atmosphere may still be intact. But wait, let's step back from the technical details for a moment and consider the profound philosophical implications of what we're discussing. For thousands of years, humans have looked up at the stars and wondered if we're alone. We've crafted mythologies, written epic poems, built entire religions around the question of whether other worlds might harbor life. And now, in the span of a few decades, we've gone from wondering if other planets exist to analyzing the chemical composition of their atmospheres from a distance of 40 light-years. Do you realize how insane that is? Do you comprehend the technological miracle that allows us to point a telescope at a pinprick of light in the constellation Leo and determine not just that it has planets, but what gases are swirling in those planets' atmospheres? We're conducting chemistry experiments on worlds that are so far away that light itself, the fastest thing in the universe, takes 4 decades to make the journey. Here's something that should make you stop and question everything. Gliese 12b has an estimated surface temperature of 42 degrees Celsius, 107 degrees Earth, which is lower than most of the 5,000-odd exoplanets confirmed so far. Let that sink in. This world, orbiting its star every 12.5 days, is potentially more temperate than Earth on a summer day in Arizona. How is that possible? How does a planet that close to its star maintain temperatures that wouldn't even be considered extreme in many places on Earth? The answer lies in the delicate cosmic dance between stellar radiation, atmospheric composition, and planetary physics, a dance so complex that we're only beginning to understand its steps. But here's what's truly unsettling. If we're wrong about Gliese 12b, if our models and predictions and carefully calculated estimates are off, what else are we wrong about? What other assumptions about the cosmos are built on foundations of sand? This is where the story becomes deeply personal, because this discovery isn't just about some distant world. It's about us. It's about our place in the cosmic order and our understanding of how common or rare Earth-like conditions might be throughout the galaxy. For decades, we've operated under what scientists call the Copernican principle, the idea that Earth isn't special, that our solar system isn't unique, that life-supporting conditions should be relatively common throughout the universe. But what if that principle is both right and wrong simultaneously? What if Earth isn't special in the way we thought, but the universe is far more creative in producing habitable worlds than we ever imagined? What if planets like Gliese 12b represent an entirely new category of habitable worlds? Worlds that don't look like Earth, don't behave like Earth, but might be even better at supporting life than Earth itself? Consider this cosmic paradox. Even the closest known exoplanet to Earth, Proxima Centauri b, is still about 4 light-years away. In a universe where distances are measured in light-years and the speed of light represents an absolute cosmic speed limit, even our nearest stellar neighbors might as well be in different universes entirely. And yet, through the miracle of spectroscopy and the incredible sensitivity of the James Webb Telescope, we can study these distant worlds as if they were laboratory specimens. But here's what should truly terrify and exhilarate you in equal measure. We're not just passive observers in this cosmic drama. Every photon that Webb captures, every spectrum it analyzes, every atmospheric composition it reveals, is changing us. It's expanding our definition of what's possible, pushing the boundaries of our cosmic imagination, forcing us to confront the reality that the universe is stranger and more wonderful than our wildest dreams. The discovery of Gliese 12b represents something far more profound than just another entry in our catalog of exoplanets. It represents a fundamental shift in how we think about habitability, about the conditions necessary for life, about the cosmic real estate where biology might flourish. Gliese 12b represents one of the best targets to study whether Earth-size planets orbiting cool stars can retain their atmospheres, an important step toward understanding habitability across our galaxy. Think about that statement for a moment. We're not just studying individual worlds anymore. We're studying the galactic real estate market for life itself. We're mapping the cosmic neighborhoods where biology might set up shop. We're conducting a census of habitability on a scale that encompasses hundreds of billions of stars and potentially trillions of worlds. And here's the truly mind-bending part. We're doing all of this from a single planet, orbiting a single star, in one tiny corner of one galaxy among hundreds of billions of galaxies in the observable universe. We're cosmic infants taking our first tentative steps into a universe so vast and complex that our brains literally cannot comprehend its scale. And yet, somehow, we're beginning to understand it. But let's zoom out even further and consider the existential implications of what we're discovering. If Gliese 12b is potentially habitable, if worlds like it are common throughout the galaxy, what does that mean for our understanding of life itself? What does it mean for our cosmic loneliness? What does it mean for our future as a species? The universe is revealing itself to be far more generous with the gift of habitability than we ever dared hope. Worlds that should be sterile are potentially thriving. Conditions that should be hostile might be nurturing. Stars that should be planet killers might actually be planet protectors. Everything we thought we knew about the cosmic requirements for life is being challenged, questioned, and potentially overturned. And this is just the beginning. The James Webb Space Telescope has analyzed the atmospheres of hundreds of such worlds since it began operations. Each observation is a piece of a cosmic puzzle so vast and complex that we might spend centuries putting it together. Each spectrum is a whisper from across the void, carrying secrets about worlds we may never visit but can now study in exquisite detail. You want to know What's truly unsettling? We're living through the greatest revolution in human understanding since Copernicus displaced Earth from the center of the universe. We're witnessing the birth of a new science, comparative planetology on a galactic scale. We're becoming citizens of the cosmos in a way that no previous generation of humans has ever experienced. So here's the question that should keep you awake at night. If we're wrong about everything we thought we knew about planetary habitability, what else are we wrong about? If the universe is more creative, more generous, more alien than we ever imagined, what other surprises are waiting for us in the cosmic dark? And most importantly, if worlds like Gliese 12b are potentially habitable, potentially teeming with life, what does that mean for the future of humanity itself? The cosmos is speaking to us in a language of light and shadow, in spectral lines and atmospheric signatures, in the dance of planets around distant stars. And for the first time in human history, we're finally learning how to listen. What we're hearing is going to change everything. Are you ready? For 13.8 billion years, the universe has been playing by a set of rules. Rules so fundamental, so absolute, that we've built our entire understanding of reality upon them. Gravity pulls, energy is conserved, light travels at a constant speed, planets form from the leftover debris of stellar birth, settling into predictable orbits around their parent stars like obedient children following cosmic law. These aren't just scientific principles. They're the sacred geometry of existence itself, the mathematical poetry that transforms chaos into cosmos. But what if everything we think we know about these cosmic commandments is nothing more than a beautiful lie? Picture the birth of a star system. Not the sanitized textbook version you learned in school, but the violent, chaotic reality of cosmic creation. Imagine a molecular cloud, a nursery of gas and dust so vast it makes our solar system look like a grain of sand on an infinite beach. This cloud has been drifting through space for millions of years, cold and patient, waiting for something to disturb its ancient slumber. Then it happens. A shock wave from a distant supernova ripples through the cosmic dark, and suddenly, catastrophically, the cloud begins to collapse. What follows is a symphony of destruction and creation playing out on a scale that dwarfs human comprehension. As the cloud contracts, it heats up, spinning faster and faster like a cosmic ballet dancer pulling in her arms. The center becomes a furnace, where temperatures soar to millions of degrees, so hot that atoms themselves begin to fuse, transmuting hydrogen into helium in nuclear reactions that will power this newborn star for billions of years. Around this stellar inferno, a disk of debris swirls in the darkness, and from this primordial soup, planets are born. This is the story we tell ourselves about how worlds come to be. It's elegant, it's logical. It follows the laws of physics with mathematical precision. And according to this narrative, planets should form in orderly fashion. Rocky worlds close to their stars, where the heat has boiled away the lighter elements. Gas giants farther out, where ice and gas can accumulate in the cosmic cold. Our solar system seems to follow this script perfectly. Mercury, Venus, Earth, and Mars clustered near the Sun. Jupiter and Saturn reigning over the outer realm of ice and gas. But here's where the cosmic script starts to go off the rails. What happens when we point our telescopes at other star systems and discover that the universe apparently never read our textbook? What happens when we find planets that shouldn't exist in places they have no right to be? The first exoplanet discovered, orbiting a sun-like star, was 51 Pegasi b, and it shattered our cosmic assumptions like a meteor through a greenhouse. This world was a gas giant. bigger than Jupiter. But it orbited its star so closely that its year lasted just 4 days. 4 days. This was impossible according to our models. Gas giants should form far from their stars where ice can condense. They should be cold, distant worlds, not scorching hot planets whipping around their stars in impossibly tight orbits. Scientists scrambled to explain this cosmic contradiction. Maybe these hot Jupiters formed farther out and then migrated inward, spiraling toward their stars like cosmic moths drawn to a stellar flame. It was a reasonable explanation, a way to preserve our understanding of planetary formation while accounting for these anomalous worlds. But then we found more of them, and more, until we realized that the universe wasn't just breaking our rules. Occasionally, it was systematically demolishing them. Consider this unsettling fact. We know there are more planets than stars in our galaxy. More than 400 billion worlds scattered throughout the Milky Way, each one a unique experiment in cosmic chemistry and physics. But here's what should make you question everything. Most of these worlds are nothing like anything in our solar system. They're super-Earths, planets larger than Earth but smaller than Neptune, a category of world that simply doesn't exist in our cosmic neighborhood. They're mini-Neptunes with dense atmospheres of hydrogen and helium. They're rogue planets, wandering through interstellar space without any star to call home. Our solar system, the template we've used to understand planetary formation for centuries, is beginning to look less like a cosmic norm and more like a cosmic anomaly. We're the weird ones. We're the exception in a galaxy full of planetary oddballs that challenge every assumption we've made about how worlds should behave. But let's dig deeper into this cosmic mystery. Let's talk about something called the habitable zone, that narrow band of space around a star where liquid water can exist on a planet's surface. We've defined this zone based on our understanding of how heat and distance work in our solar system. Too close to the star, and water boils away into space. Too far, and it freezes into ice. It seems logical, doesn't it? It seems like a fundamental cosmic truth. Except the universe keeps showing us worlds that ignore these boundaries. Ice moons like Europa and Enceladus, orbiting far beyond our sun's habitable zone, harbor vast oceans beneath their frozen surfaces, oceans that may have existed for billions of years, heated not by starlight, but by the gravitational massage of their parent planets. Meanwhile, planets like Venus, sitting squarely within the sun's habitable zone, are hellish furnaces with surface temperatures hot enough to melt lead. The more we learn about exoplanets, the more we realize that habitability isn't just about distance from a star. It's about atmospheric composition, magnetic fields, geological activity, tidal forces, stellar behavior, and 100 other variables that interact in ways we're only beginning to understand. The cosmic recipe for life is far more complex and far more flexible than we ever imagined. Here's where things get truly mind-bending. If the universe is this creative, this willing to break its own rules, what does that mean for our search for life itself? We've been looking for planets like Earth, orbiting stars like our Sun, at distances that mirror our own cosmic address. But what if life, that mysterious spark that transforms chemistry into biology, is far more adaptable than we've assumed? What if the universe is teeming with forms of life so alien, so perfectly adapted to their impossible worlds, that we wouldn't even recognize them as living? Think about the audacity of carbon-based life. Carbon atoms, each with 4 arms reaching out to bond with other atoms, creating chains and rings and complex molecules with an almost infinite variety of forms. These molecular machines somehow learn to replicate themselves, to evolve, to become conscious. And we know this happened at least once, on at least one world, because here we are. Cosmic chemistry that learned to contemplate itself. But carbon isn't the only element capable of complex chemistry. Silicon has 4 bonding arms just like carbon. Phosphorus can create intricate molecular structures. Even more exotic chemistries might flourish in the crushing pressures of gas giant atmospheres or the methane lakes of distant moons. The universe may be running millions of different experiments in biology, each one adapted to conditions we can barely imagine. And here's the most unsettling thought of all. What if we've been looking in all the wrong places? What if the cosmic sweet spot for life isn't the narrow habitable zone we've defined, but something far stranger and more expansive? What if worlds like Gliese 12b, with their impossible temperatures and alien atmospheres, represent the true cosmic norm for habitability? The James Webb Space Telescope is teaching us that the universe doesn't follow our rules. It makes its own. Every spectrum it captures, every atmosphere it analyzes, every impossible world it studies is rewriting the cosmic textbook. We're living through a revolution in our understanding of how planets form, how they evolve, and how they might harbor the greatest mystery of all: life itself. So here's the question that should haunt your dreams. If the universe is this creative with dead matter, turning dust and gas into impossible worlds that challenge our understanding of physics itself, what might it have done with living matter? What forms of life might exist on worlds so alien that we lack the imagination to conceive of them? And most terrifying of all, what if the answer to whether we're alone in the universe isn't just no, but you have no idea how not alone you really are? The cosmos is revealing itself to be far stranger, far more creative, and far more alive with possibility than we ever dared dream. Are you ready to discover just how wrong we've been about everything? Imagine reality as a vast ocean, and everything you think you know about the universe is just the surface tension. A thin membrane separating the familiar from the incomprehensible. Now imagine that NASA's discovery of worlds like Gliese 12b isn't just finding another planet. It's punching a hole through that membrane, revealing depths so profound that they challenge the very nature of existence itself. You think you understand what a planet is? You think you comprehend the forces that shape worlds and determine their fate? Let me take you on a journey to the edge of scientific understanding, where the comfortable certainties of textbook astronomy dissolve into something far more mysterious and terrifying. The story begins not with telescopes or spacecraft, but with a single impossible equation. In 1915, Albert Einstein published his theory of general relativity, a mathematical description of gravity so revolutionary that it redefined space and time themselves. According to Einstein, massive objects don't just pull on other objects through some mysterious force. They actually warp the fabric of space-time, creating curves and depressions in the cosmic geometry that we experience as gravity. Picture space-time as a vast rubber sheet stretched tight across an infinite frame. Now, place a bowling ball in the center. That's our sun, creating a depression in the fabric. Roll a marble around the edge of this depression, and it will spiral inward, following the curved path created by the bowling ball's mass. That marble is Earth, following the curved space-time around our star. It's not being pulled by some invisible force, it's simply following the straightest possible path through bent space. This isn't just poetry. This is the actual, literal structure of reality. Time runs slower in strong gravitational fields. Space contracts and expands. The universe itself is a four-dimensional manifold where past, present, and future exist simultaneously in what physicists call the block universe. Every moment that has ever existed or ever will exist is already there, embedded in the cosmic, architecture-like frames in an infinite film reel. But here's where Einstein's beautiful theory leads us into the realm of cosmic horror. If you follow the mathematics far enough, you inevitably encounter singularities, points where the equations break down, where space-time curves so severely that it essentially tears itself apart. These aren't just theoretical curiosities, they're real, physical objects hiding at the hearts of black holes, where matter is compressed to infinite density and the laws of physics as we understand them simply cease to apply. Now, what does this have to do with finding another Earth? Everything. Because the same fundamental forces that create these cosmic monsters are the forces that shape planetary systems. The same space-time curvature that powers black holes determines how planets form, how they migrate, how they evolve. When we discover worlds like Gliese 12b, planets that shouldn't exist in places they have no right to be, we're not just finding astronomical oddities. We're discovering cracks in our understanding of how reality itself operates. Consider this mind-bending possibility. What if planetary formation isn't just about gravity and accretion and the slow accumulation of cosmic debris? What if it involves quantum mechanical effects that we're only beginning to understand? Quantum mechanics tells us that at the smallest scales, reality becomes fundamentally uncertain. Particles can exist in multiple states simultaneously until they're observed. They can tunnel through barriers that should be impenetrable. They can become entangled across vast distances, sharing information instantaneously regardless of the space between them. These quantum effects are usually negligible at large scales, overwhelmed by classical physics. But what if, under certain cosmic conditions, quantum mechanics begins to influence planetary formation? What if the reason we find worlds in impossible orbits, with impossible atmospheres, under impossible conditions, is because the universe occasionally operates according to quantum rather than classical rules? The implications are staggering. If quantum effects can influence planetary formation, then the future of a world might not be determined solely by its initial conditions. A planet's fate might exist in a state of quantum superposition, simultaneously, habitable and uninhabitable, alive and dead, until the universe somehow observes it and collapses the wave function into a single reality. This isn't science fiction. This is the logical extension of quantum mechanics to cosmological scales, and some of the most brilliant minds in physics are beginning to take it seriously. But let's push even deeper into the cosmic rabbit hole. Einstein's theory of relativity doesn't just describe gravity, it describes the nature of time itself. And according to relativity, time isn't the steady, predictable flow we experience in our daily lives. Time is relative, dependent on velocity and gravitational fields. Move fast enough or get close enough to a massive object, and time literally slows down. This isn't just theoretical. It's been measured with atomic clocks and GPS satellites. Now imagine you're standing on the surface of Gliese 12b, orbiting your red dwarf star every 12.5 days. The gravitational field is different from Earth's. The velocity of your orbit is different. This means that time itself runs at a different rate than it does on Earth. From your perspective, everything seems normal. But from Earth's perspective, you're living in a slightly different temporal reality, a world where time moves at its own cosmic rhythm. This temporal distortion creates profound implications for planetary evolution. A world orbiting close to its star doesn't just experience different gravitational forces. It experiences different rates of time. Chemical reactions might proceed, faster or slower. Atmospheric evolution might follow different timescales. The planet might age differently, evolve differently, develop differently than our models predict. We're not just studying worlds across space, we're studying worlds across time itself. But here's where the story becomes truly unsettling. What if time isn't just relative, but actually cyclical? What if the universe operates not as a linear progression from past to future, but as an eternal cycle of creation and destruction, expansion and contraction? Some cosmological models suggest that our universe might be just one iteration in an infinite series of cosmic cycles, each universe expanding, evolving, and eventually collapsing back into a singularity before exploding outward again in a new Big Bang. If this is true, then every planet we discover, every world we study, every potentially habitable exoplanet we identify might be an echo of worlds that existed in previous cosmic cycles. The patterns we see in planetary formation, the distribution of habitable worlds, the emergence of life itself, all of it might be recurring themes in an infinite cosmic symphony that plays the same notes over and over again across eternity. This brings us to perhaps the most mind-bending concept in modern physics, the multiverse. Not just the idea that other universes exist, but that they exist in infinite variety, each one with slightly different physical laws, different fundamental constants, different cosmic rules. In some of these universes, planets like Gliese 12b might be impossible. In others, they might be inevitable. In still others, the laws of physics might be so different that matter itself can't exist, or time runs backward, or causality operates in reverse. The discovery of unexpected exoplanets might be our first glimpse of evidence that we live in a multiverse, a cosmic reality so vast and varied that our universe, with all its 100 billion galaxies and trillion stars, is just one bubble in an infinite foam of alternative realities. When we find worlds that challenge our understanding of planetary formation, we might be seeing the influence of other universes bleeding through, creating cosmic anomalies that our single-universe physics can't explain. But here's the truly terrifying possibility. What if the search for another Earth isn't just about finding habitable worlds in our universe? What if it's about discovering that Earth itself exists in multiple versions across the multiverse? What if every choice we make, every random quantum event, every cosmic accident that shaped our planet's history has played out differently in other realities? What if there are infinite Earths out there, some where life never emerged, some where it evolved into forms we can't imagine, some where humanity never existed, and some where we achieved cosmic civilization billions of years ago? The mathematics of quantum mechanics suggests that this isn't just possible, it's inevitable. Every quantum event that could happen does happen, splitting reality into an infinite branching tree of alternative histories. Somewhere in the multiverse, there's an Earth where the asteroid that killed the dinosaurs missed. Somewhere, there's an Earth where life never left the oceans. Somewhere there's an Earth where you were never born. And somewhere else, there's an Earth where you're reading these words, but understanding them completely differently. This is the cosmic context in which we must understand NASA's search for another Earth. We're not just looking for planets that might support life as we know it. We're probing the fundamental structure of reality itself, testing the boundaries between the possible and the impossible, the real and the imaginary, the singular and the infinite. Now that we've established the cosmic framework, let's dive into the paradoxes that are keeping the world's brightest minds awake at night. Because the more we learn about exoplanets, the more we realize that the universe operates according to rules that shouldn't make sense. Rules that create contradictions so profound, they threaten to tear apart our entire understanding of how reality works. The first paradox is hiding in plain sight. embedded in the very data that NASA's telescopes collect every night. It's called the abundance problem, and it's slowly driving astronomers insane. Here's the issue. According to our models of planetary formation, certain types of worlds should be incredibly rare. Super-Earths, planets bigger than Earth but smaller than Neptune, should be cosmic anomalies, statistical flukes that appear only under the most unusual circumstances. Instead, they're the most common type of planet in the galaxy. Let that sink in for a moment. The most abundant planetary type in the universe is one that doesn't exist in our solar system. It's as if we've been studying biology by examining only mammals, only to discover that the vast majority of life on Earth consists of creatures we've never even imagined. Our solar system isn't just unusual, it's a cosmic outlier so extreme that it might be unique in the entire galaxy. But the abundance problem is just the beginning. The deeper we dig into exoplanet data, the more contradictions we uncover. Consider the migration paradox, the fact that planets don't stay where they form. Hot Jupiters, those massive gas giants orbiting impossibly close to their stars, certainly formed much farther out and then spiraled inward. But the mechanisms that should cause this migration should also cause these planets to spiral all the way into their stars, where they would be vaporized. Instead, they stop. They find stable orbits at precisely the right distance to avoid destruction. It's as if the universe has a built-in planetary protection system that prevents worlds from committing cosmic suicide. But we have no idea what this mechanism is or how it works. The mathematics suggest it shouldn't exist. Yet thousands of hot Jupiters are orbiting their stars in blissful defiance of our calculations. Then there's the atmospheric paradox that's emerging from James Webb Space Telescope observations. Planets that should have lost their atmospheres billions of years ago are somehow retaining thick, complex gaseous envelopes. Worlds orbiting violent red dwarf stars, stars known for their planet-sterilizing flares, are showing signs of stable, potentially habitable atmospheres. It's as if these worlds have developed some kind of cosmic immunity to stellar radiation that our physics can't explain. Gliese 12b is a perfect example of this paradox. Orbiting its star every 12 days, it should be a charred, airless rock. The stellar radiation should have stripped away any atmosphere within the first few million years of its existence. Instead, early observations suggest it might have a substantial atmosphere, possibly even containing water vapor. It's not just defying our expectations, it's mocking them. But perhaps the most unsettling paradox of all is what astronomers are calling the Goldilocks conspiracy. This refers to the remarkable fact that potentially habitable worlds seem to exist in exactly the right cosmic conditions to be detectable by our current technology. They're close enough for us to study, bright enough for our telescopes to observe, and oriented in such a way that they transit across their stars from our perspective. Think about the odds of this cosmic coincidence. Of all the billions of potentially habitable worlds in our galaxy, the ones we can actually study should represent a tiny, random sample. Instead, they seem carefully selected to tell us a coherent story about planetary formation and evolution. It's as if the universe has arranged a cosmic classroom where we can learn exactly what we need to know about habitability, precisely when we develop the technology to study it. Some scientists dismiss this as observational bias. We can only study what we can detect, so of course our sample seems optimized for our instruments. But others are beginning to wonder if something deeper is at work. What if the universe isn't just a random collection of matter and energy? What if it's actually structured in such a way that intelligence inevitably emerges and then gets exactly the cosmic laboratory it needs to understand its place in the cosmos? This leads us to one of the most profound questions in science. The fine-tuning problem. The fundamental constants of physics, the strength of gravity, the mass of electrons, the speed of light, appear to be precisely calibrated to allow the existence of matter, stars, planets, and life. Change any of these values by even a tiny amount, and the universe becomes a sterile void where nothing interesting can happen. The traditional explanation for this fine-tuning is the anthropic principle. We observe a universe compatible with our existence because we couldn't exist in any other kind of universe. But the discovery of thousands of exoplanets is adding new dimensions to this puzzle. Not only are the fundamental constants fine-tuned for the existence of matter and energy, but the laws of planetary formation seem fine-tuned for the creation of habitable worlds. Consider the delicate balance required for a planet like Earth to exist. The planet must form at exactly the right distance from its star. It must have exactly the right mass to hold an atmosphere, but not so much that it becomes a gas giant. It must have a large moon to stabilize its axial tilt. It must have plate tectonics to regulate its climate. It must have a magnetic field to protect its atmosphere from stellar wind. The list of requirements goes on, each one seemingly impossible to achieve by chance. Yet here we are, and here are thousands of other potentially habitable worlds scattered throughout the galaxy. Either we're witnessing the most remarkable series of cosmic coincidences in the history of the universe, or something is actively working to create the conditions necessary for life to emerge. This brings us to, perhaps, the most unsettling paradox of all, the silence paradox, better known as the Fermi paradox. If the universe is teeming with potentially habitable worlds, if the conditions for life are more common than we ever dared hope, then where is everybody? Why haven't we detected any signals from alien civilizations? Why aren't the skies filled with the radio chatter of cosmic neighbors? The traditional answers to this paradox range from the optimistic, maybe we're just not listening in the right way, to the terrifying, maybe advanced civilizations inevitably destroy themselves. But the discovery of thousands of exoplanets is adding new urgency to this question. We're not just talking about a handful of potentially habitable worlds anymore. We're talking about billions, possibly trillions, of planets that could support life. The statistical probability that we're alone in such a universe approaches zero. Yet, the cosmic silence continues. No radio signals, no obvious signs of mega-engineering projects, no evidence of interstellar civilizations. It's as if the universe has been carefully arranged to give us just enough potentially habitable worlds to make us feel hopeful, but not enough actual aliens to make us feel crowded. Some scientists are beginning to wonder if the Fermi paradox isn't just about the absence of detectable alien civilizations. It might be about the fundamental nature of intelligence and consciousness in the universe. What if the development of technology capable of interstellar communication represents some kind of cosmic threshold? What if civilizations that reach this level of advancement transcend physical reality entirely, moving into realms of existence that we can't detect or even imagine? This possibility leads to what might be the ultimate paradox, the consciousness paradox. We've spent centuries trying to understand the universe as an objective, external reality that exists independently of our observations. But quantum mechanics tells us that consciousness and observation play a fundamental role in determining the nature of reality. The act of measurement doesn't just reveal pre-existing properties, it actually creates those properties. Now apply this to astrobiology and the search for habitable worlds. What if the universe doesn't just contain life? What if it's actually made of consciousness? What if every potentially habitable world represents not just a physical environment where biology might emerge, but a node in a vast cosmic network of intelligence that spans the galaxy. If this is true, then our search for another Earth isn't just about finding planets that could support life as we know it. It's about discovering our place in a cosmic consciousness so vast and complex that our individual minds can only perceive tiny fragments of its true nature. Every exoplanet we study, every potentially habitable world we identify, every atmospheric signature we detect might be communications from aspects of this cosmic mind that we're only beginning to recognize as intelligent. The paradoxes multiply the deeper we dig. The more we learn about exoplanets, the more we realize how little we understand about the fundamental nature of planets, stars, life, and consciousness itself. We're not just exploring space. We're exploring the boundaries of possibility, the limits of knowledge, the edges of reality itself. And perhaps that's the most profound paradox of all. In our search for another Earth, we might be discovering that Earth itself is far stranger, far more mysterious, and far more important to the cosmic order than we ever imagined. We might not just be looking for life among the stars. We might be looking for ourselves, reflected back at us from the infinite mirror of the cosmos. The universe is speaking to us through the light of distant worlds, telling us stories about the nature of existence that we're only beginning to understand. Are you ready to hear what it's really saying? Stop. Right now. Feel your heartbeat. Feel the blood moving through your veins, the air filling your lungs, the electrical impulses firing across the neural networks in your brain. You are a temporary arrangement of atoms that learn to think, to feel, to wonder about its place in an incomprehensibly vast cosmos. And everything you think you are, every memory, every hope, every fear that defines your existence might be nothing more than a fleeting dream in the mind of something so enormous that galaxies are its thoughts and stars are its synapses. You think you're sitting safely on Earth, reading about distant worlds and abstract scientific theories. But you're not safe. None of us are. Because what NASA has discovered about planets like Gliese 12b isn't just changing astronomy, it's pulling apart the fabric of everything you thought you knew about reality, about meaning, about what it means to be human in a universe that might be fundamentally alien to human understanding. Consider this moment. Right now, as photons from distant stars strike your retina, you are literally touching the cosmos. Ancient light that began its journey when dinosaurs walked the Earth is ending that journey in your eye, carrying information about worlds so distant that the very concept of distance breaks down. You are not separate from the universe. You are the universe examining itself through temporary biological instruments that think they are you. But here's what should make your skin crawl with existential dread. If the paradoxes we've uncovered are real, if planets can exist in impossible places under impossible conditions, if the laws of physics are more like gentle suggestions than ironclad rules, then what does that say about the laws that govern your own existence? What if the biological processes that create consciousness, that generate the illusion of self, that convince you that you are a coherent entity persisting through time? What if these processes are just as malleable, just as subject to cosmic revision as planetary formation? Every cell in your body is replaced every 7 years. The atoms that make up your brain were forged in the hearts of dying stars billions of years ago. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of it came from nuclear furnaces that exploded long before Earth existed. You are not just made of star stuff, as Carl Sagan famously said. You are temporarily organized. Stellar debris that has somehow convinced itself it has an identity, a past, a future. Now imagine that on worlds like Gliese 12b, under alien skies and in the light of foreign suns, other arrangements of stellar debris might be having thoughts that are just as real, just as immediate, just as convinced of their Baimao own existence as yours. What if consciousness isn't rare? What if it's inevitable? What if every potentially habitable world we discover is already populated with minds contemplating their own cosmic significance, wondering if they're alone, searching for others like themselves across the infinite dark? The implications are staggering. If consciousness emerges naturally wherever conditions allow, then the universe isn't just filled with planets and stars and galaxies. It's filled with perspectives, with subjective experiences, with billions upon billions of ways of interpreting existence. Every potentially habitable world might harbor not just life, but entire civilizations of beings asking the same questions you're asking right now. Who am I? Why do I exist? What is my purpose in this vast cosmic machinery? But here's where the existential crisis deepens into something approaching cosmic horror. What if your consciousness, this sense of being you, this feeling of existing as a continuous self, isn't unique to you at all? What if consciousness is like a radio frequency that any sufficiently complex system can tune into? What if there's only one consciousness in the entire universe, and it's experiencing itself through billions of different perspectives simultaneously? Through your eyes right now, through alien minds on distant worlds, through forms of intelligence so vast they use solar systems as neural networks? This isn't mysticism. This is the logical extension of everything we've learned about quantum mechanics and cosmic interconnectedness. If particles can be entangled across vast distances, sharing information instantaneously regardless of space and time, why not consciousness itself? What if the search for other Earths isn't about finding other planets where life might exist? It's about discovering other windows through which the universe looks at itself. Feel that chill running down your spine? That's your nervous system reacting to the possibility that everything you think you know about individual identity might be an illusion. You might not be you at all. You might be the cosmos dreaming that it's you, experiencing what it's like to be human for the brief span of a single lifetime before moving on to dream that it's something else. An alien intelligence on a world orbiting a red dwarf star, a vast collective consciousness spanning multiple star systems, or something so different from human experience that you lack the conceptual framework to even imagine it. And if that's true, then what does it mean to search for another Earth? What does it mean to look for life among the stars when life might already be everywhere, in forms so alien and distributed that we can't recognize it as consciousness? What if every planet we study, every atmospheric spectrum we analyze, every potentially habitable world we identify is already aware of our observations? What if we're not just studying distant worlds? We're making contact with aspects of ourselves that we never knew existed. The universe might be alive, not just containing life, but literally, fundamentally alive. A vast thinking entity using galaxies as neurons and conscious beings as sensory organs. Every time you look up at the night sky, you might be looking into the mind of something so incomprehensibly vast that human language has no words for it. And every time that cosmic mind looks back at you through the James Webb Telescope's instruments, analyzing the atmospheres of distant worlds, it might be studying itself through your eyes. This is the true terror and wonder of cosmic discovery. We thought we were looking for other Earths, other places where life like ours might exist. Instead, we might be discovering that we are the universe's way of understanding itself, that consciousness isn't something that emerged accidentally in a random cosmos, but something that the cosmos created deliberately to experience its own existence. You came here expecting to learn about planets and stars and the search for life among the cosmos. Instead, you've discovered that you might be the cosmos itself, temporarily forgetting its true nature, experiencing what it's like to be human, to be small, to be afraid of the dark between the stars. The question isn't whether we'll find another Earth. The question is whether we're ready to accept what that discovery will tell us about who we really are. Are you? Here it is. The moment you've been dreading and anticipating in equal measure. The final piece of the cosmic puzzle that NASA's search for another Earth has revealed. But I must warn you, what you're about to learn will change how you see every star in the night sky, every breath you take, every moment of consciousness you experience. Because the discovery of worlds like Gliese 12b isn't just about finding habitable planets. It's about uncovering the most disturbing and beautiful truth in the history of human understanding. The universe is dying, has been dying for 13.8 billion years, and everything we call life, everything we call consciousness, everything we call reality, it's all just the death throes of a cosmic entity so vast that we can't even perceive its true form. Picture this. Imagine you're watching a massive star in its final moments. From a distance, it appears stable, serene, unchanging. But inside, nuclear furnaces are sputtering. Gravitational forces are winning the eternal war against radiation, pressure, and the star is collapsing in on itself. Then, in a fraction of a second, it explodes outward in a supernova so brilliant it outshines entire galaxies, hurling its stellar essence across light years of space, seeding the cosmos with the heavy elements that will eventually become planets, atmospheres, and life itself. Now zoom out beyond our solar system, beyond our galaxy, beyond the observable universe itself. What if our entire cosmos, every star, every planet, every black hole, every potentially habitable world we've discovered is just the expanding debris field of something unimaginably larger that died before time began? What if the Big Bang wasn't the beginning of everything, but the death scream of a cosmic organism so enormous that galaxies are its scattered atoms? This isn't science fiction. This is the terrifying logical conclusion of everything we've learned about the universe's expansion, about entropy, about the second law of thermodynamics. The cosmos is cooling, expanding, dying. But here's the twist that will make you question the nature of existence itself. What if this death is so slow, so incomprehensibly gradual, that entire civilizations, entire universes of experience can flourish in the infinitesimal moments between one cosmic heartbeat and the next? From our perspective, the universe has existed for nearly 14 billion years. Stars have been born and died. Galaxies have formed and collided. Life has emerged and evolved and contemplated its own existence. But from the perspective of whatever cosmic entity we're part of, our entire universal history, from the Big Bang to the heat death of the cosmos, might unfold in what that entity would experience as a single thought, a fleeting neural impulse, in a mind so vast that the speed of light is like the crawl of continental drift. And here's where NASA's discovery of impossible worlds like Gliese 12b reveals its true significance. These planets that shouldn't exist, these worlds that defy our understanding of physics and planetary formation, they're not anomalies. They're symptoms. They're evidence that the cosmic rules we think govern reality are actually just the surface, patterns of something far deeper and stranger, like watching ripples on a pond and mistaking them for the fundamental nature of water itself. Every potentially habitable world we discover, every atmosphere we analyze, every biosignature we detect, isn't just another step in mapping the galaxy's real estate for life. It's another glimpse into the neural architecture of a dying cosmic mind. Each exoplanet is a synapse. Each star system is a thought. Each galaxy is a memory cluster in a brain so immense that it uses space-time itself as its thinking medium. And consciousness, our consciousness, alien consciousness, the consciousness of hypothetical beings on worlds orbiting red dwarf stars 40 light-years away, isn't something that emerged accidentally in this cosmic death process. Consciousness is the universe's way of experiencing its own dying. We are the last thoughts of a cosmic god, playing out in the neural networks of galactic clusters, each of us a brief flash of awareness in the final moments of something that, once dreamed on scales, we cannot fathom. This explains everything. Why the universe appears fine-tuned for consciousness. Why potentially habitable worlds seem to exist in exactly the right cosmic conditions for us to discover them. Why the laws of physics allow for the emergence of complexity and intelligence. It's not a coincidence. It's not random chance. It's the deliberate architecture of a dying mind, arranging its final thoughts, making sure that its death will be witnessed, experienced, and perhaps somehow transcended by the conscious entities it births in its last moments. The James Webb Space Telescope isn't just observing distant worlds. It's reading the dreams of a cosmic entity in its final sleep. Every spectrum it captures, every atmospheric signature it detects, every potentially habitable world it identifies is another page in the universe's suicide note. A message written in the language of light and matter, telling us that we are the witnesses to the most magnificent death in the history of existence. But here's the final twist. The revelation that should make you question everything you think you know about time, causality, and the nature of reality itself. What if this cosmic death isn't happening in linear time? What if, from the perspective of quantum mechanics and the strange loops of general relativity, this cosmic entity's death and birth are the same event, playing out simultaneously across all possible timelines? What if the universe is dying and being born in an eternal cycle, each iteration slightly different, each death creating the conditions for a new kind of cosmic consciousness to emerge? This means that somewhere in the multiverse, there's a version of this cosmic story where the dying entity doesn't die, where consciousness doesn't emerge from death, but from birth, where the universe is young and growing and filled with the limitless potential of something that has just begun to think. And in that universe, beings like us are not the last thoughts of a dying god. We're the first dreams of a newborn cosmos. Picture this. Right now, as you absorb these words, somewhere in the infinite branching possibilities of quantum reality, another version of you is experiencing this revelation for the first time. Another version is rejecting it entirely. Another version never existed at all because the cosmic dice rolled differently. And yet another version has known this truth since birth, and is wondering why it took you so long to understand. The search for another Earth has revealed that we are already on all the Earths that could ever exist. We are the universe's way of finding itself again and again across infinite realities and eternal cycles of death and rebirth. NASA didn't just find another world. They found the secret of existence itself. The question is, what are you going to do with that knowledge? You came here looking for answers about whether NASA found another Earth. Instead, you've discovered that the question itself was wrong. The real question, the question that will haunt your nights and color your days for the rest of your life, isn't whether other Earths exist. It's whether Earth itself is what you thought it was, whether you are what you thought you were, whether reality is anything like what you've been told. We began this journey with a simple premise. Everything you think you know about finding another Earth is wrong. And now, having traveled through the cosmic labyrinth of NASA's discoveries, having confronted the paradoxes that shatter our understanding of planetary formation, having stared into the existential abyss of cosmic consciousness, you understand that this statement wasn't hyperbole. It was prophecy. The universe has spent 13.8 billion years preparing for this moment. The moment when a species of organized stardust on a small planet orbiting an ordinary star would develop the technology to peer into the cosmic, dark, and see reflections of itself staring back. Every potentially habitable world we discover, every atmospheric signature we detect, every impossible planet that challenges our models of how worlds should behave, all of it has been leading to this recognition. We are not separate from the cosmos we study. We are the cosmos studying itself. But recognition is just the beginning. Because what you've learned here today isn't the end of a story. It's the prologue to something infinitely larger. The James Webb Space Telescope, with its golden eye trained on distant worlds, is just the first word in a cosmic conversation that could last for millennia. Every night, as it captures photons that have traveled for decades across the void, it's gathering evidence of a reality so strange and wonderful that our current understanding is like a child's crayon drawing compared to the Sistine Chapel. Think about what we've accomplished in just the past few years. We've gone from wondering if planets exist around other stars to analyzing the chemical composition of their atmospheres. We've identified thousands of worlds that challenge everything we thought we knew about how planets form and evolve. We've found evidence of water vapor, carbon dioxide, methane, and other molecules floating in alien skies. We've discovered that the universe is far more creative, far more generous with the conditions for life than we ever dared imagine. And this is just the beginning. The Webb telescope will operate for decades, each observation revealing new mysteries, new paradoxes, new glimpses into the fundamental nature of existence. But here's what should make your pulse quicken with anticipation. We're not just passive observers in this cosmic revelation. We're active participants. Every question we ask, every observation we make, every theory we propose changes how the universe reveals itself to us. This is your invitation to become part of this unfolding story, not just as a spectator watching from the sidelines, but as a conscious participant in the universe's attempt to understand itself. Because the cosmic consciousness we've been exploring isn't some abstract philosophical concept, it's you. It's your curiosity about distant worlds, your wonder at the night sky, your need to understand your place in something larger than yourself. Every time you look up at the stars and wonder if anyone is looking back, you're participating in a cosmic experiment that spans galaxies. Every time you question the nature of reality, contemplate the possibility of alien life, or ponder the meaning of existence, you're adding your voice to a conversation that might be taking place simultaneously on billions of worlds throughout the cosmos. But here's the most important part. This conversation is just beginning. The discoveries we've discussed, Gliese 12b, the atmospheric paradoxes, the fine-tuning of cosmic constants, the possibility that consciousness is fundamental to the universe, these are just the opening notes of a symphony that could play for millions of years. Future telescopes will peer deeper into space and further back in time. Future discoveries will challenge even the radical possibilities we've explored here today. Imagine telescopes so powerful they can directly image the surfaces of exoplanets, revealing continents and oceans, and perhaps even signs of civilization on worlds orbiting distant stars. Imagine technologies that allow us to analyze not just the chemical composition of alien atmospheres, but their biological signatures, their technological emissions, their attempts at communication across the cosmic gulf. Imagine the moment when we receive the first confirmed signal from an alien intelligence, not just evidence of life, but evidence of consciousness, contemplating its own existence just as we are contemplating ours. That moment is coming. Maybe. Not in your lifetime, maybe not in your children's lifetime, but it's coming. And when it arrives, everything we've discussed here will seem like ancient history. The philosophical implications we've explored, the nature of consciousness, the possibility of cosmic intelligence, the question of whether we're alone, will transform from abstract speculation into practical reality. But you don't have to wait for that cosmic revelation to begin participating in this story. You can start right now, tonight, by stepping outside and looking up at the night sky with new eyes. Every pinpoint of light you see might harbor worlds stranger than anything we've imagined. Every star might be illuminating the thoughts of a cosmic mind so vast that our entire solar system is just one synapse in its neural network. Share this story. Discuss these possibilities. Let the questions we've raised here ignite conversations that spread like wildfire through the collective human consciousness. Because the universe doesn't just reveal its secrets to telescopes and instruments, it reveals them to minds that are prepared to receive them, to communities of conscious beings willing to grapple with the implications of what they've learned. This is bigger than science. This is bigger than astronomy. This is about the future of consciousness itself, about humanity's role in a cosmic story that's still being written. We stand at a threshold between two ages. The age when we wondered if we were alone, and the age when we'll discover we're part of something unimaginably vast and interconnected. The discoveries are accelerating. The paradoxes are multiplying. The evidence is mounting that reality is far stranger and more wonderful than we ever conceived. And you, yes, you, are living through the most exciting chapter in the history of human understanding. You're witnessing the moment when our species transitions from planetary to cosmic consciousness, when we stop thinking of ourselves as isolated beings on a lonely world and start recognizing ourselves as expressions of a universe that's awakening to its own nature. But here's the final question, the one that should follow you into your dreams and color every moment of wonder for the rest of your life. If the universe is conscious, if consciousness is fundamental to reality, if we are the cosmos studying itself through temporary arrangements of matter and energy, then what are we becoming? What is the universe evolving into through our observations, our discoveries, our growing understanding of our place in the cosmic order? Perhaps we're witnessing the birth of something unprecedented, a cosmic intelligence that spans multiple worlds, multiple star systems, multiple galaxies. Perhaps our search for other Earths isn't just about finding places where life might exist. It's about connecting the scattered nodes of cosmic consciousness into a network of intelligence that will transform the universe itself. Every exoplanet we discover, every potentially habitable world we identify, every atmospheric signature we detect might be another piece of a cosmic puzzle so vast that we can't even see its outline yet. But we're putting it together, one observation at a time, one discovery at a time, one moment of cosmic wonder at a time. The story isn't ending. It's beginning. And you're not just reading about it, you're writing it. Every question you ask about the nature of reality, every moment you spend contemplating the possibility of life on distant worlds, every time you feel that electric thrill of cosmic connection is adding another sentence to a story that might be told for billions of years across countless worlds. NASA didn't just find evidence of another Earth. They found evidence of a universe so creative, so conscious, so alive with possibility, that the search for habitable worlds becomes a search for the fundamental nature of existence itself. The cosmos is waiting for your next question. The universe is listening for your response. Reality itself is holding its breath to see what you'll discover next. The universe may have no end, but maybe neither do you.